on the transverse magnification or linear magnification only. Okay, after learning this, so we will now get into the image tracing for a concave mirror. Means like I'll keep an object a certain distance. Where that image will be, I have this mirror formula, and also by ray diagram, I'm going to show it. I think this will be like a very fundamental thing which I'm going to present here. Okay, let me consider this for a concave mirror. So we are going to start the image tracing for a concave mirror. I could have done with only ray diagram. Since now we know mirror formula and magnification, it'll be very easy to demonstrate even the mirror formula. I'm going to combine both, like image tracing, and also we are going to learn how we are going to use mirror and magnification formula. Okay, let me start it. So what is the type of focal length of the mirror? Minus 10 centimeter. First case, the object is at a distance of minus 10 centimeter, 30 centimeter, and height of the object, length of the object is 2 centimeter. This is data. And what is object? Object is in fact real object. Okay, let's see that one. Okay, first, what about the mirror formula will apply? I'll come to the ray diagram. What is the direction of incident ray? Towards left, because this object, no, it will emit the rays. Luminous object, extended luminous object it is. The incident, these are incident rays, they go, strike the mirror and come. You can see this. These are the incident rays. Then this direction should be taken positive, no? According to sign convention. Okay, where the object is at a distance of minus 30 centimeters. So from the mirror formula, what is the object distance? Minus 30. Focal length should be minus 10. Why negative focal length? Because it is measured opposite to incident ray. Because all the distance I should measure from the pole. So we'll get it. So if I solve it, I'll end up with minus 15 centimeter. Let's calculate the linear magnification. Substitute V and U with sign. V is how much? Minus 15. U is how much? Minus 30. So this will be minus 1/2. This is a linear magnification. So how you define magnification? Height of the image by height of the object. So what is the magnification formula? How much magnification? Minus 1/2 plus 2. So what is the image? We are getting minus 1 centimeter. What do you mean negative? Inverted. Inverted and diminished. You see the height of the image. Less than height of the object. So it will be diminished here. So now where is the object kept? Real object is kept beyond the center of curvature. Okay, let's come to the ray diagram. Now we know the image should be between F and C, because focal length is 10 centimeter. What is radius of curvature? Will be 20 centimeter. So where the image I'm getting minus 15. So the image will be between F and C. Now let's come for ray diagram. I'll send one ray parallel to principal axis. Where is the principal axis? There's a principal axis. In short, I'm calling only axis here, to save time. Okay, let's. Now I'll consider a ray, incident ray coming from the luminous extended object. Let it be parallel to principal axis. After reflection, it should pass through the focus, the red color one. It'll come like this. Then I'll send another ray, which is incident at pole. It should get reflected symmetrically. Angle of incidence should be called angle of reflection. Here also. Angle everywhere, law of reflection is all good. So the ray will get reflected symmetrically. The reflected ray will pass through the red color, will intersect the red color. Where these two rays reflected is intersect, there should be the position of the image. So I'll draw a line, vertical line. This will be the image, extended image will be formed here. So what are HO and HI, which we indicated? So this should be the HO and this is HI. So this will be the reflected ray will come like this. This is the extended image. Fine. So finally, what is the conclusion? So anything can we conclude about the image? Image is what? Real. First, where the image is between C and F. Real, inverted, and diminished. So what is the conclusion? If object is kept, real object is kept between beyond center of curvature. If the real object is kept beyond center of curvature, this is center of curvature. Beyond means it will be like this on the right side of center of curvature here. Then the image will be formed between F and C, will be real, inverted, and diminished. So I think this will be, so to draw this exact ray diagram, you should take protractor, scale, eraser, pencil. The mirror formula is simplified. Directly, it gave us answer, no? What is the height of the image? 1 centimeter. Did I took any optical instruments or any geometrical instrument? Nothing, no? So with the help of the mirror formula, we are able to predict the position of image and the height of the image also. You can see there's the advantage of mirror formula and the magnification formula. I need not to draw ray diagram, that it will tell us. If you draw ray diagram, take scale protractor, then you should measure this length. I think this will be much easier, no? Convenient for numerical solving. Similarly, now I just the same focal length of the lens for everywhere will continue with the same concave mirror. Object is kept between C and F, where object distance is now minus 15 centimeter and the height of the object 2 centimeter. No. Where's the object? Object between F and C. Object is kept between focus and center of curvature. The rays in the incident ray after reflection from mirror should pass through focus. Then another ray, incident pole after reflection will get reflect symmetrical and will intersect the red color ray, another reflected ray at this point. So this will be the location of image. So where the object is between C and F, where the image is beyond C. Inverted. Look at the height of the image greater than that of the height of the object. So it will be magnified, inverted, and it's a real, no? For real object, we are getting, in fact, a real image. Let me write in the ray diagram that the image, I means image, O means object. I think by this time everyone knows that convention. Huh? Okay, no, this is so. Let's use the mirror formula. Let's use mirror formula 1 by V. So then what is U? U minus 15 minus 10. So this will become minus 30 centimeter. After solving this, then magnification. Substitute all with sign. Why minus 15? Yes, sir, in the mirror formula, why minus 15? Okay, where is the object at a distance 15 centimeter? I'll measure in this direction. No? And what is the direction of incident ray? The direction of incident ray is towards right, because the incident rays in what direction they're moving? Towards left. And I'll measure all the distance from the pole. So at what distance the object is at a distance of 15 centimeter, or you measure from the pole. No? So the distance now you measure opposite to incident ray. So therefore it should be negative. Focal length also opposite incident ray. This should be negative. Okay, substitute again. This minus 30 plus 2. So let's calculate height of the image equal to M into HO plus 2 plus 2. Minus 2, this will be negative. So this will be minus 4. So what is the height of the image will be minus 4 centimeter. So what is the conclusion we can make it? Final image beyond C, real, inverted, and magnified. So if object is between C and F, the image will be real, inverted, and magnified. Next question. If object is kept at center of curvature, where the image will be, according to from the ray diagram, this will be the direction of incident rays. Again, the focal length of the mirror, the same mirror. Object is kept at exactly minus 20 centimeter. Height of the object. Let me write the data here. Yeah, look at this one. Where the object is at center of curvature. Then the incident ray will move towards left. Then there's a incident ray parallel to principal axis. After reflection should pass through focus. Oh, something I didn't draw properly. Yeah. So after reflection, it will pass through the focus. Then array incident at pole will be reflected symmetrically. Both will intersect here. We'll get the position of image. Some I could not draw properly. Just manage it. This will be the position of the image. Fine. This one. So now let's get into the mathematics. How we derive this one. 1 by V. Directly, let me write it here. So where is the distance? Minus 20. Solving this, I'll get V minus 20 centimeter. What is the magnification? So what do you mean by magnification? Minus 1. The height of the image is in fact equal to height of the object. Look at the height of the object, 2 centimeter. What is the height of him? Minus 2 centimeter. And where the object and image will be at same position. If object kept at center of curvature, image will be at center of curvature only. I'll keep it, I'll move it down. Yeah. And now what is the conclusion we can make it? Let me shift it down a bit so that I can write the data. Yeah. Now object, where is the object or real object at center of curvature? What about image? Image will be real. At center of curvature. Inverted and same size. Okay, all this corresponds for this one. Okay, let's take the other condition. For mirror of focal length minus 10 centimeter, object is at minus 6 centimeter. Let me keep it here. Let me solve height of the object plus 2 centimeter. Okay, from the formula 1 by V equal to 1 by F. Let me substitute all the things. U is equal to how much? Minus 6 minus 10. If I solve this, 1 by V equal to 1 by 6 minus 1 by 10. So V will become 60 by 4 or 15 by 2. No, sorry, 30 by 2 or it will be 15. 10 minus 6 by 60. So this will be 15 centimeter. Okay, look at this one. So where is the object? Object is somewhere here between pole and focus. Where do image I'm not getting, I'm getting somewhere plus means on the left side of the pole here. So what was the image we took? So what was the object? Real object. What was the image? Will be virtual. You can ask question like, so what do you mean by real virtual image? That's a primary question. Now we have two situations in front of us. Look at this image form. It is formed by the converging reflected rays. No? So therefore this image must be real. This image I is formed by converging reflected rays. Look at this image. It is formed by diverging reflected rays. I'll send a ray parallel to principal axis. After reflection will pass through focus. I'll send a ray. I'll let the incident ray strike the pole of a mirror. After reflection should diverge again should diverge from a point. This will be reflected. Look at these two reflected rays. They're diverging from a point. Okay, this will be the position of the virtual image. And look at these two, they are reflected rays. They're diverging. So therefore the image will be formed as virtual. So look at these two reflected rays. They're converging. So therefore the image form will be real. So how to say real or virtual image? If the image is formed by the converging reflected rays, real image. If the image is formed by diverging reflected rays, it will be virtual image. That's the primary idea of this problem. Okay, I'll write down that. Let me find out magnification. I'll conclude that point. Magnification equal to V by U plus 15 minus 6. 15 by 6, 12, 2.5, magnification plus 2.5. 15 by 6 it is there. So it will be 12, 6, 2, 3. Yeah, 2.5 it will come. Then height of the image. Five centimeter. So is it magnified? Yes, it's magnified. So what is the basic idea? No, if object is kept between pole and focus, what about the image? Image will be. Let me conclude here. Image will be virtual, erect, and magnified on either side of pole. Okay, how to trace out real or virtual image? So definitely whose help we are going to take it? We are going to take help of the reflected rays. Reflected, if the image formed by the converging reflected rays should be real image. Let me write, indicate that one. I think okay, no. So compare these two very, because I wanted to give the idea of the real and virtual images also. Okay, this is about the image formation. Last one. If object is at focus. If object is at focus. If object is at focus, what about the image? So according to the formula, object is kept at focus and towards right, it is positive. So what about image? Image I'll get at infinity. What do you mean by infinity? Far away, it is like this. So now let's do one thing. I'll send a ray parallel to axis. The incident ray what happen will strike the mirror, so it will be parallel to principal. After reflection should pass through focus. Then other incident ray, which is incident at pole after reflection will. So these two are parallel now. So if object kept at focus, image will be at infinity. Okay, this is about for real object. We have seen all these conditions. Similarly, for virtual object, how to deal with virtual object. What do you mean by object? These are incident rays. These are incident rays. If the incident rays converge at a point, that should be the location of virtual object. In fact, there's a mirror should be there. I can show with respect to vertical line. I could have drawn a big mirror. It looks a little bit odd. That's why I'm just showing with respect to this one. So the incident rays converge at a point. So this should be the location of virtual image. Again, we'll take the same formula. Object is at +6 centimeter. Focal length is -10. Height of the virtual object is +2 centimeter. Let me write the data in this way. So towards right should be positive because the incident rays are moving towards left, or say towards left. Okay, let me use again the same mirror formula. So this, I don't know. This will be +6 -10. 1 by V. V equal to 60 by 16. It will be negative. So this should be equal to 30 by 8. 30 by 8, 15 by 4. V equal to, or further, this will be 4 3 ja 12. 3.75 centimeter. Then linear magnification. Object distance is +6. So it will be diminished. You can see from here 15 by 24 or plus 15 by 24. It will be less than 1 and it will be erect. Positive, I got it. So height of the image oh, sorry, this will be 30 by 24, no? What happened? Yeah, this will be the height of the image. So look at this one. So this will be less than 2 centimeters, 30 by 24. So can I simplify this one? Yeah, so 6 by 3 by 2. 6 5 ja 5 by 4. So look at the height of the image, less than 2 centimeters will be diminished here. What about this? Again, this image is formed by the converging reflected rays. So therefore, this should be a real image. So concave mirror for virtual object forms real, erect, diminished image. Where is the object? Object is virtual objective. So what about the image? Image will be virtual, erect, diminished, and on either side of pole or between pole and focus, or better not try that one. Better select on either side of the pole. So what is the conclusion we can make it? Concave mirror for real object. Okay, this is the final conclusion. I'm coming to the conclusion part. concave mirror altogether for real object. For real object. So what is the image is real inverted and magnified or diminished. It depends upon the condition. Similarly, for real object, image is virtual, erect, and magnified. For virtual object, image is real, erect, and diminished. So what is not possible? For virtual object, it cannot form virtual image. I think this is very, very important. So concave mirror for virtual, for real object, image will be real, inverted, magnified, or diminished. For real object, image will be virtual, erect, and magnified. For virtual object, image is real, erect, and diminished. For virtual object, it cannot form virtual image. So what is not possible for virtual object? Concave mirror cannot form virtual image. There's a primary conclusion. Okay.